So ArcGIS Velocity has been around for a while. It's new to me. There was a project that came up where the requirements of that project married up nicely to the capabilities of ArcGIS Velocity. And during that project, I started to sort of understand that Velocity it's a powerful set of tools. It's very versatile. It's very intuitive. There's no coding involved. It's all kind of, drag and drop style sort of workflows and wizards. And I started to realize how useful it's going to be for a number of other organizations. And I wanted to put together a number of videos of using it against real Australian feeds and real Australian data sets that have been collected, and also base the workflows upon previous projects that we've done in the past, but using ArcGIS Velocity. Two things I wanted to call out. It's pure software as a service, so it's an extension to your ArcGIS Online for Organization subscription. As part of SaaS, underneath the hood, it's got a microservices architecture. And I mentioned that really just to sort of point out that it doesn't have some of the same scalability limitations that you might have had by spinning up your own infrastructure and your own software on that infrastructure. The SaaS model also, which I think is a really important one, it has built-in high availability, data redundancy, and disaster recovery. And those three alone, trying to sort of match that with your own infrastructure and managing that infrastructure can get very costly. And that's all been taken care of with ArcGIS Velocity. The second thing I wanted to call out is it's two things here. It's not just streaming analytics, but it's also batch analytics. It's two things in the one product. So, and by streaming analytics, I mean it's got the ability to ingest and visualize a wide range of incoming data feeds. And by batch analytics, I mean being able to perform big data analytics on stored data. And that stored data doesn't just have to be in feature services. It can be in blob storage or a bunch of files in an S3 bucket. So you kind of have these two separate things, but in the same product. And because the two kind of marry up nicely. If you're connecting to streams of data, you usually accumulate larger data stores that you want to then start doing batch analytics on and scheduling that. So with that, this first workflow I wanted to show is a fairly common one, but it used to be reserved for bigger organizations, mainly because of the infrastructure you'd have to spin up. And that's around the kind of the duty of care and being able to, if you have a field force, monitoring the locations of that field force in tandem with monitoring an incident feed, such as bushfires, and sort of then bringing those two together, doing proximity analysis to work out, well, is my field crew in proximity to this new incident? And if so, do something, notify them. So we're going to do that today with a combination of Velocity and ArcGIS field maps, which includes tracking capability if you enable it. Two feeds to set up. The first one is going to be the incident feed. This is the Emergency Management Victoria incident feed. It has the important latitude and longitude of the incident. Maybe we only care of incidents of type bushfire, and we only care about the status where they're out of control. The metadata behind these feeds will tell you kind of the values that you might want to sort of hone in on. If we take this JSON feed from my ArcGIS Online account, I can open up the Velocity application. And with Velocity, what we want to do is create a feed. And this is really just ingesting the data so that we can then perform later on a real-time analytic against it. So I'm going to do an HTTP poll against that JSON endpoint. There is no authentication. There is no custom URL parameters we need to pass to it. However, there is this root level node called results. So just to unpack this list into the fields, we put in the root node there. We check the field types are what we expect. We can rename some of these fields on the fly. We can remove what we don't need, and we can add fields as required. I'm going to use this last updated date, which is an epoch, but you can also pass a date as well. The location fields, of course, lat longs, and the last updated date is what I want to focus in on. which is an epoch. The tracking ID is important. That is the unique ID field in the incidents. Just stops incidents stacking up as features on top of each other each time you poll. It'll just update them as required. I'm going to run this every 15 seconds. Actually, no, that's not. You don't want to put too much stress on the other person's systems. Every 30 seconds is enough. And we do want to do that all day, every day. You can set up a particular time period on Monday to Friday if you like. We're also going to publish an associated feature layer. And this is really just a dumping ground to decide to put those incidents into somewhere to store the data as well. This is really neat. You can actually have a Lambda architecture where you can, after that retention period, push the data into a cold store to still do batch analytics against. I'm not going to be doing that. And we can choose aggregation styles. So if you were using a more higher velocity feed, you can have an aggregation, kind of a hash style, to sort of help you visualize where those incidents are accumulating. This is now deploying that service and also the feature service to store the data in. The interface gives you the ability to check out what's going on as it deploys that. You can also check out the metrics. So once it finishes initializing, it'll show you the velocity, and it'll be pretty every time it polls will be fairly consistent. The events will change depending on if it's a good day or a bad day. Whilst that's initializing, what I want to do is actually backtrack. So in my organization, I've already set up a field maps project that has tracking enabled. So on the organization, I have tracking enabled. And in my application here, this has tracking. So it's not just limited to field maps, but field maps is the common one a lot of people will be using. And within field maps, I haven't actually required it because they can choose to opt out of it, but you can actually say, look, for this map, they will have to be, if they're going to open it, they're going to have to go through the process of being tracked. I'll send you links in the video description below on how you can set this up. The point being is I have a layer in my organization that actually accumulates these tracks and has the last known positions of my field crews. So back in Velocity, I'm going to create a second feed. Create feed. In this case, it's going to be an ArcGIS feature layer, and it is the location tracking within my organization, and it is the last known location of my field crew. Pull that in. The where clause can be useful, like there's all of the fields like accuracy. Maybe you want to filter out anything that seems to be wildly off. Maybe anything that's worse than 50 meters you kind of want to strip out. I'll leave it in. Or maybe there's a particular category of users you want to sort of ignore. Whatever you're trying to do. But for this, I want everyone. The schema, again, you might want to strip some of these out, but these might be useful to me later. I can always come back later and remove what I don't need. Timestamp field. The track ID is the user. Yep. And I do actually want to run this a bit more actively. Let's do this every 15 seconds. Let's do 10 seconds. I feel like every second counts. And this is my last known locations. That'll do. I don't want to publish a feature layer because it's already been persisted into my data store in ArcGIS, but this might be, if I've done some filters, maybe you might want to do that. But so that's now created my two feeds. That'll start to deploy this feed to be used. Let's just go back to the other feed. So what happens next is once we've got these feeds, the next video will be then using these to create a real-time analytic. But let's just make sure this is actually collecting data now. So we can see already it's now running. That suggests that there is some data flowing through. It's only just started. So what I really want to do is actually, let me look at this on a map. So if I open up the service, it's 5:20 on a Monday in May. let's just look at the raw data, 44. Seems like quite a lot, actually. Visualization. Hopefully not all on Null Island. Got the lat longs the right way. Yep. So then we can start to see our feed. And this is where you can start to override symbology and maybe use the EMV symbols and save that, so when people use it in their web maps downstream, it'll be familiar to the end user. So previously we configured two feeds, one to fetch the Emergency Management Victoria incidents, and the second one, our field crew using field maps. They've opted to have tracking enabled with fetching their last known locations. Now what I've done is I've actually enabled that and used that and commuted to work, and using that track file that comes out of that, I'm able to then use that in an additional feed, which allows me to simulate the exact same schema that would come out of field maps and use it as a simulator file, which just speeds up the whole testing experience. From there, the next step is to create a real-time analytic. I have one here that I want to rip apart. I've just started that up just before this happened, so that's just starting up and initializing. But let's have a look at the logic. So it'll be easy for me to explain this logic and by cross-comparing it to the map. So what we have is, on the left, is we have those two feeds. We have the Emergency Management Victoria feed, and we're actually taking that feed and writing all of it into this incidents layer, which is this layer here. And we're then filtering it down and say, well, look, we only, for our incident detection, we want to strip out anything that is not going to be of concern. So we're stripping out the false alarm ones. I can see just then that the animation of these lines suggests that this is now initialized and these events are flowing through. With that filtered down incident feed, we're then creating some 5-kilometer buffers around those incidents. And visually, I want to see where those buffers are. So I'm actually sending those buffers to a stream layer here, which allows me to then see that on the map, which is this layer at the bottom here. And there we go. There is an incident just after this last known location here. But that's okay. We'll wait for it to loop around again. Up at the top here, the last known locations, which is this track file here. And what's missing is the EMV incidents. So I've probably just missed a refresh setting on one of my layers. And there we go. So there's the incident. Let's see if there's any other incidents. So the incidents are the real deal. That is actually what's happening right now. It's not a huge amount for a rainy day. It's pretty normal, I guess. Okay, so the other logic that's going on here is we're now taking that buffer feed, the buffers, and the field crew locations, and using this one here, which is a detect incidents. And it's a very simple one. Basically, if they enter this buffer, we'll start an incident. And we don't have a closed condition, which means it's the direct opposite. So as they exit that buffer, it'll then close off this incident. And we actually want to write all of those incidents to files. So we want to record that in a layer. And we also then want to take those start and end events and use them in a notification scenario. So we can, in this case, send an email, but we could communicate with other messaging systems. And we'll look in a subsequent video about how we can pass them across to Microsoft Automate, and then the other clever things you can do in Microsoft Automate. So with that, I'm going to just hang around here and pause the video. And we're back. So it's now looped around and they're coming back down the freeway, and I happen to know that they will enter this buffer, which will then trigger this incident detection to create a new open incident and flow through this logic up at the top here. This is the beauty of simulation files, because you can sort of, obviously don't want to be sending people out chasing, what would happen if you get close to a bushfire. You can start to create simulation data or take previous data and kind of use it in your scenario workflows. So whilst that's, let's see if I can quickly pull up my inbox. And we should see, depending on how quick that SMS gateway is, that SMTP gateway is, how quickly we'll get an email. And let's have a look. So So they've entered the geofence. I have a feeling I probably... Oh, there we go. So there's our email. This is it's interesting. That's to do with, you've got to get your SMTP settings right to make it look like it's coming from a trusted source, which I haven't quite done yet. And it then uses some of the fields that are in that incident to allow us to see, provide that additional context to the person that you need to send this to. And for me, this is to my inbox, but what you want to do is actually send them an SMS, so they're made aware of it, or whatever messaging system they have. And we'll look at that in the Automate one. Looks like I had a refresh setting missed there, but that is where the incident started. I've actually kind of decided to keep the incidents where it's ongoing, which can be useful for later on when you need to understand their movements after they got that warning, to sort of work out, what did they, ignore the warning and kind of carry on progressing towards the incident. One of the things that I would do to extend this service, there's a calculate distance one. I'd probably put that in after the detect incidents to then also have that information to send this person, say, by the way, they are 2 kilometres away. They're now 3 kilometres away. And you can kind of use that information to then help make decisions. So this will carry on all the way to the other end, where the incident is then closed off.